we've got the Leaving Cert 2024 area and volume question, which has incorporated distance, speed and time. If you're watching this on the distance, speed, time playlist, you can stop at the end of A. If you're watching it to incorporate the area and volume, continue on till the end of the question. Although this is a Leaving Cert question, it is perfectly appropriate for Junior Cert higher level, and often they change the questions up a little, so really make sure you practice it if you are watching it and you are a Junior Cert as well. It's not a mistake. Let's get going. In the Wimbledon Tennis Tournament 2023, the fastest women's serve was by Arina at 121 miles per hour. Use the conversion rate of 1 mile equals 1.61 kilometers to convert to 121 miles to kilometer. In Ireland, we use kilometer, but in the UK, they use miles. You'll often maybe see on a car that's being imported from England or the UK that it comes up in miles, or perhaps an older car, because we used to record distance in miles as well. So what I've done is I've put the conversion rate in here, and the same as converting money, it'll always either be multiply or divide. So what I've done is I've put the miles under the miles, the kilometers under the kilometers. If 1 mile is 161, how many are 121 of them? If you're really unsure, you would try both ways. You would multiply and divide and try and work it out. But if you've got 161 multiplied by 121, it'll tell you 194.81 kilometers. And how I know I'm definitely right, I always have a look here and I say, small, big, is this smaller, is that bigger? Yes. So I'm pretty happy that the answer is 194.81 kilometers. Had you have divided that in this case, that wouldn't be correct, or 121 divided by 161, just using common sense, it wouldn't be correct because it's much smaller than 121. Okay, convert an hour into seconds. There's 60 minutes in an hour and 60 seconds in 1 minute. So what we need to do is hours to minutes to seconds. So in 1 hour, there's 60 minutes, and in each minute, there are 60 seconds. So 1 times 60 times 60 is 3,600 seconds. That comes up every couple of years here and there in different ways. So make sure we know that one, okay? We'll keep moving because it is quite basic. Use your answers in part AI and AII to convert 121 miles per hour to meters per second. So here we have to remember that we changed the miles into kilometers. And how many meters are in 1 kilometer? We need to know this information off by heart. There are 1,000 meters in 1 kilometer. So I peek back here. I need to change these kilometers, these 194.81 kilometers, into meters by timesing it by 1,000, giving me 194,810 meters. You can just do that in your calculator, or what I did was I moved the decimal point forward. All over the seconds, which was 3,600, giving me 54.11388 and I pop back up and make sure I get full marks, they want this to 2 decimal places, giving me 54.11 meters per second. We'll keep moving. If you were just watching this video for the distance, speed, time, you can stop here. But if you'd like to go on with the area and volume, which is suitable for Junior Cert higher level or Leaving Cert ordinary level, you may do so. Tennis balls. Okay, so we got tennis balls here and they're in the shape of a sphere. For professional tennis matches, tennis balls are of slightly different sizes. The smallest size allowed has a radius of 3.27. Find the surface area of the tennis ball and give your answer in centimeters squared to correct to 2 decimal places. So remember that the radius is from the center out to any point at all on the ball, okay? The area of a sphere is in your little booklet here, which you'll get on the day. First couple of pages, and it's in on page 10. The surface area is everywhere you can touch, but it won't say surface area here, it just says area. So the area formula is 4 pi r squared. Do I know what the radius is in this question? Yes, I do. 4 pi, open bracket, the radius, which is 3.27, and squared. So you're going to pop that into the calculator for me. And we'll see what we get there. If you're unsure where pi is, you're going 4, you're hitting your shift button. And if you look down the very bottom here, there's a small little pi. Kind of hard to see on the calculator, or pardon me, on the video. That little guy there. Bracket 3.27, close bracket squared. And that will give me 134.37. And you want this to 2 decimal places. That's why I stopped at the 37, because the third decimal was a 0. Centimeters squared. And we'll keep moving because it's not really all that difficult, okay? The cross section of the tennis ball is shown here in the diagram on the right. And the ball is made of air-filled centre and a rubber layer of uniform thickness. That means that it's the same thickness the whole way around. The external radius of the tennis ball is 3.4. The internal radius of the rubber ball is 3.1. Find the volume of the rubber layer. So what you want to think about is you've basically got a big ball there. Okay, let's pretend this is the big one. And the radius of the big one is 3.4. And then you've got this smaller inner ball with a radius of 3.1. But what you need is the actual difference. It's all this little portion. So if you found the volume of the big ball, found the volume of the air inside or the small ball, and took them away, you'll get the volume of the rubber. So the volume of a sphere formula is back in your booklet here, and it's 4/3 pi r cubed. That's 4/3 pi. Radius is 3.4 cubed, and into your calculator. Then the volume of the small ball is 4/3 pi 3.1 cubed, and into your calculator. So let's just find those out there. Hopefully you can see it's quite challenging to see on the video. 4 over 3 pi, so you're hitting shift and this guy down here to get him up, bracket 3.4, close bracket to the power of 3, giving me 164.636. I'm going to add an extra decimal, and at the end, I like to round at the end. That's making it absolutely perfect, but you can round there if you wish. Now I'm going to go back and I'm going to do 4 over 3 pi 3.1 cubed. Instead of typing it all out, I'm just going to hit the back button and change it, giving me 121.788. The big, take away the small, will leave me with the rubber that is left, which is 39.574, and rounding that, just going to give that a quick revision if you don't mind, sorry. I just think I did a little calculator error, pardon me. Volume 4 over 3. Perfect. $164.636. Take away 121. Was he supposed to be a 4? Let me just double check. Sorry about this, but I don't want to record the whole video again. Yes, he's supposed to be a 4. Apologies. So 164.636 take 124.788 will give me 39.848. Sorry about that, but I don't want to have to go back and record it all. So it's 39.848, and then I'm going to round to 2 decimals. So I look at my third, which is above 5, and pushes that 4 up to a 5. So find the volume of the big one, find the volume of the small one, make sure you write down the right number, not like me. Take them away and we get 39.85. I know when we're in classes, lots of students would say, well, what would happen if that happened in real life, like me writing down the 121? So I would lose a point here, which would make my answer incorrect. So this here is worth 10 points and I would actually only get 7 because I made a slip or an error here and then I continued it on so I'd get the full marks from here. So this one error would knock me back 3 points. So it's worth double checking things. Right, on to the last bit, part D. The diagram on the right shows the smallest closed cylindrical container that contains 3 identical tennis balls, arranged one directly on top of another. The radius of each tennis ball is 3.4. The height of the cylinder is h. Show that this full height is 20.4. What we need to remember is if it's 3.4 from here to here, it's also 3.4 from here to here. So there's 1 radius, 2 radius, 3 radiuses, 4, 5, 6. And they're all 3.4 each. So you could write out 3.46 times or 3.4 times 6 leaves me with 20.4. So what you needed to know there, or the information that was important, is that from the center to any point on the tennis ball at all is 3.4. And that's how you know 3.4, 3.4, and so on. So 20.4 centimeters. Hence calculate the volume of the cylinder. That's all right. The volume formula, you're going into your booklet here again. In on page 10, volume is pi r squared h. The pi will go straight in. The radius, we just established the radius was 3.4. From the center out to any point anywhere. And then your height, we just worked out the full height is 6 radiuses at 20.4. Into your calculator, you will get 740.8629. Go back and read it. They wanted the nearest whole number. So you look at the number after the decimal, giving me 741 centimeters cubed. And that's that guy. He's not too bad. So the next part is the surface area of a box. The 3 tennis balls could also be arranged one directly on top of another inside of a closed rectangular box. So here it was cylindrical. Now it's a nice boxy shape. Find the surface area of the smallest such box. The surface area formula is not in this booklet. You have to learn it off by heart, unfortunately. Basically, you're finding the area of the top, the area of the bottom, the area of one side, the area of another side, then the area of the front and the area of the back. You can just learn this formula off by heart. What I do, for me to have learned it, I went 2, 2, 2. Then I put my pluses in. Now, what I'm going to do is just look at the front face first. I might just pop a wee colour on him. So I'm looking at this face here first. So here, okay, I'm going to do length by width. Then you can look at this back one here, or height by depth, and then the top one. And you've got 2 of each. So I do 2LL is always how I start. The lengths first, then the height times the width, and then I take the 2 different ones and I put those together, width by height or height by width. There's lots of different ways of learning it off by heart. That's just how I've learned it, but of course, whatever works for you. So this piece at the bottom is just a little square, and that's going the whole way across the diameter of the tennis ball. Now, if the radius from up here was 3.4, that means that the whole way across would be 6.8. Then this piece going back will also be 6.8. And we already know the height. That height from here to here was 20.4. So we actually have all the pieces of information now. You've got twice bracket, bracket, plus, twice bracket, bracket, plus, twice bracket, bracket. So you have to kind of say, what are you going to call the length? What are you going to call the width? What are you going to call the height? Well, the length and the height in this box is the same. And I suppose the width is 6.8, okay? So 20.8 times 6.8, 20.4, apologies, times 6.8. I just called that out incorrectly. Then the length again is 20.4. The depth this time is 6.8. Whatever way you want to look at the depth. And then you want the top of the box and the bottom of the box. So it's 6.8 by 6.8. You see that, like, there's kind of like a square on the top and a square on the bottom. And you pop it into your calculator. So twice 20.4 by 6.8 is 277.44. This here is the exact same. And then here, gives me 92.48, and we total them all up. Giving me 647.36 centimeters squared. Please don't let this confuse you too much. Really, it's just a square at the top, a square at the bottom. You see how you could draw that out? And it's 6.8 by 6.8. And then there's two of them. That's where I'm getting this here from. So you could just do it like that, okay? 6.8 times 6.8, and you get 46.24. And there's 2 of them, hence we're timesing by 2. There's actually, because of the shape of the box, 4 of the same thing now, which is 20.4 by 6.8. Because you got the front, this guy here, the back, and the side, and they're actually all the same. Hence why I've done that twice, 277.44. So you technically have 4 of them. That's another way to go about it. So here I've got 46.24 for the top, for the bottom. I've got 277.44 for the front and the back, and another 20.4 down and 6.8 over for the side and the side. The exact same thing, guys. And then you just total them all up. That's 100% a legitimate way of doing it. So that's a really good question.